Okay, this is the FPGA board right here. I programmed it so that it'll do an adder, incrementer, subtractor, and a multiplier. So we're going to do the table on the last sheet of the lab. The A value is 1100 and the B value is 0110, and we're going to go through all of the operations with those numbers, which is 8. So first of all, we're going to do the addition. So we have 12 plus 6, which gives me 18. Now it shows on here we have a carryout bit, and we have the first bit right here, bit 1, which is 2. So we have 2 plus the carryout, which can be considered the 5th bit. So that carryout is 16 plus the 2, that gives you 18. Alright, so on the results on the table, you will put 10000010. Alright, and that's how it's going to proceed from now on. So we're going to go to the second operation, which is Z right here, 001. So we're going to press down on the Z button, which is the last button on the right, and this should give me A minus B, which is 12 minus 6. So it should give me 6 again. It should look like this: 1001. 0110. Alright, and sure enough it did, 0110. It shows the lights right there, and I have the carryout bit and the overflow bit. Alright, and then we're going to go to increment A, which is Y. So we're going to press on Y, and it increments A from 12 to 13. So you got 1101. None of the flags are thrown. Alright, and now we're going on to multiplication, which is Y and Z. So we got 12 plus 6, which gives us 72. So when you press it down, it gives us 8 plus 64, which is the 6 bit right there, bit 6. So we have bit 3 and bit 6 lighting up. So that's 8 plus 64, which is 72. Alright, now we're going to go on to our bitwise operations. Now in the bitwise operations, I switched up my not A and my A XOR B. So for 110, it's going to be not A, and for 111, it's going to be A XOR B. So again, we got A as 1100 and B as 0110. So now we're going to go A and B. A and B is going to produce the value 0100. So let's see if that produces that. Yep, 0100. Alright, and for the bitwise operations, only LD5, which is the 0 flag, will show up. So that's what we're going to be using for our 0 flag, is only LD5 for the bitwise operations. Now we're going to A or B. Now A or B will produce 1110. So let's do A or B. 1110. Yep, sure enough it is. No 0 flag or anything. Alright, now we're going to go to not A, which is 110, which should give me the opposite of whatever A is. So A is 1100. It should come out to be 0011. Alright, 0011. And now we're doing XOR. So A XOR B is all 3 of the buttons down. So press all three of the buttons down, it should give me 1 0 1 0 1 0 1 0. Alright, now we're going to switch up A and B. Now A is going to stay the same. It's going to say 1 1 0 0, but we're going to change B to all 0. So A plus B is just showing the value of A, because A plus 0 is just A. So we still have 12 right there. So that's the first operation. Now we're doing A minus B, which is the same thing. We have 12 as our output, and LD4 is showing as a negative flag. That just means when we're doing subtraction that this first bit is considered the negative flag. So that's why it's like that. And now we're going to increment A, which is the same thing as before, which will give me 13. Alright, so we got 13. Now we're going to do multiplication, and it should produce a 0. Yep, produce the 0, but no 0 flag. Alright, and now we're doing the bitwise operations. So we got A and B, which should give me all zeros. And there goes my 0 flag right there. Alright. And with multiplication, we're not using the 0 flag, because all of the bits are for 8. For the 4 bits that multiply together, we're using all 8 bits as our output. So you won't see any flags. You just see all zeros for 0 times anything. Alright, the A and B, it shows all zeros, so we see the 0 flag right there. Now we're doing A or B. Now this should produce 1 1 1 0. A or B, 1 1 0 0. Oh yeah, that's right, because we got 1 1 0 0 as our A input, so only the first two bits, bit 3 and bit 2, will be showing up as actual ones. Alright, now we're going to do not A, which is the same thing as before. It would be 0 0 1 1 again, 0 0 1 1, and A XOR B, which will produce 1 1 0 0 again. Alright, A XOR B. Alright, that shows the table on the back. I hope this suffices. Thank you.